the experiment called shunt clipper, that is nothing but above reference. Okay, this is nothing but a circuit diagram. Here the signal generator, here we can set frequency and input voltage. Input voltage is for 6 volts peak to peak and frequency 1 kilohertz should be set in the signal generator, and 10 kilo ohm resistor series with the signal generator, and diode, and reference voltage, that is nothing but RPS, and this is the expected transfer characteristics and expected output waveform. Okay, now let's get into the breadboard connection. Before getting to the breadboard connection, let's understand theoretical part. Here clipping above reference, we are series and shunt, same equation I am going to use. Let the voltage be clipped to say 2 volts and expected output voltage is 2 volts, V volt maximum 2 volts, and V volt is equal to V reference plus VD, VF, you need to do the correction, that is nothing but VD, and V reference is equal to, we want V reference is equal to V naught minus VD. Here V reference is equal to, we know V naught 2 minus VD is nothing but 0.6, that is nothing but threshold voltage, and V reference is equal to 1.4. This is nothing but a reference voltage calculation. We need to set 1.4 volts reference voltage and 6 volts peak to peak input voltage, and we expect 2 volts clipped off above the reference. Assume R value is equal to 10 kilo ohm. Okay, this is the calculation. Okay, I think all of you understand the calculation. Now let's get into the breadboard connection. We already made the connection as per the circuit diagram. Okay, as per the circuit diagram I already made the connection. Okay, 1 kilo ohm resistor, diode, and input signal generator. I set 6 volts here, and frequency 1 kilohertz. Okay, I think all of you know how to set input voltage and frequency, and I connected input signal generator supply to the input to the breadboard, input signal generator to the breadboard, and breadboard input to the first yellow sine waveform, first channel, and output to the channel 2. Okay, now let's understand about this waveforms. Okay, this is the expected graph output waveform as per the connection, and as per the theoretical part, this is the expected output waveform. Now let's analyze the waveform through the DSO, digital storage oscilloscope. Here you can observe the peak to peak voltage, input voltage is 6 volts, and hertz 1 kilohertz input. What is the output? How to see output? We need to select only output only. We need to select I remove input and just I want to see output. See here, I am not applied any reference voltage. We need to apply reference voltage up to 1. As per the calculation 1.6 is 1.4. As per the calculation 1.4. I need set. Okay, here observe total peak to peak value is 4.5. Here we need only 2 volts clipped of above reference. So 1 volts, 2 volts, 1 2 boxes into 1 voltage per division into 2, that is nothing but 2 volts clipped off. This is how we need to check the output value. Okay, we can check the transfer characteristics also. We can check transfer characteristics also. Now for that one we need input also. I think all of you understand how to okay, go to the display. Here display is there, display, and we need to set to the XY. Okay, this is the expected transfer characteristics as per the theoretical value. As per the theoretical characteristics, this is the expected graph. We need to check accurately. Now I am going to set that one. Now we can observe both input and output simultaneously. Okay, now we want XY transfer characteristics. As per the theoretical value, this is the XY transfer characteristics. Okay.